In the last few videos, I explored different ways to convert rotational motion into linear motion, a simple crank slider mechanism, and a linear guide driven by a belt. In this video, I'm testing another approach, a linear guide powered by a lead screw. For now, it's just a quick proof of concept. The linear guide, as before, consists of a simple carriage that moves along two linear guide rods. In the belt-driven version, the motor's rotation was translated into linear motion through a belt attached to the carriage. In the lead screw drive, we instead use a nut, called a lead nut, which is fixed to the carriage. The guide rods keep the carriage from rotating, so when the lead screw turns through the nut, the carriage can only move back and forth along the screw's axis. Since I don't yet have a proper lead screw, I'm just using a regular M5 bolt as the screw and an M5 nut as the lead nut. In the 3D printed carriage, I added a small slot for the nut and heat inserted it into the PLA using my soldering iron. The bolt is connected to the shaft of this NEMA 17 stepper motor using a small coupling. And that's really all there is to it, so let's power it up and see it in action. Some obvious improvements would be, first, mounting the lead screw properly on both ends, for example with a bearing, so it doesn't wobble around as much. Second, fixing the lead nut in a more stable way, maybe by enclosing it from both sides. I could, for instance, print the carriage in two parts and screw them together with a lead nut sandwiched in between. If you have any other suggestions, please let me know in the comments. Thanks for watching and see you next time.